Hi, this is javinkharod, a chemical engineer by profession, going to discuss today's topic, hydrotreating. Now, what is that? Hydrotreating process, they are becoming increasingly important in refinery work to meet more stringent environmental guidelines. Most products of crude and vacuum distillation in refinery contain significant amount of sulfur that must be removed prior to further processing or use. Hydrotreating and hydrodesulfurization refer to set operation that remove sulfur and impurity. During hydrotreating, crude oil cuts they are selectively reacted with hydrogen in presence of catalyst, relative high temperature and moderate pressure. The process converts undesirable aromatic, olefin, nitrogen, metal and organometallic compound in the stabilized product. Some of the hydrotreated cuts they require additional processing to meet final product specifications. Now, this lecture explains the basic hydrotreating process focusing on two or most important petroleum product naphtha and diesel. This is described how the hydrotreatment process different between the two distillation cuts and look forward. Hydrotreatment environmental standard for fuel become increasingly strict and significant. Now, why hydrotreatment are necessary? Petroleum refinery transform crude oil into useful fuel and product while satisfying technical government and safety requirements. In addition, the must comply environmental policy increasingly limited amount of sulfur and other impurities in fuel. Hydrotreatment process reduces impurity petroleum product which increasing efficient fuel and reduces production harmful commercial byproducts such as NOx and SOx. Hydrotreatment also help to satisfy final product specification. Contaminant can affect performance, downstream unit operation, catalyst, and even en- engine. And one of the most common issue, nickel catalyst poisoning by sulfur, that is chemisol in chemical bags. Now, hydrotreatment efficient method remove several compounds, include sulfur is most critical compound to remove. It is present nearly all crude oil, feedstock, sulfur, mercaptan, sulfide, disulfide, polysulfide, and thiophenols. Nitrogen, a typical treated with hydrogen gas and transformed into ammonia gas. Oxygen is react with hydrogen and eliminate as water. Most oxygen in distillation cuts is not present oxygen gas but bonded to hydrocarbon. Olefin, they are volatile, unstable, not desirable in fuel. Olefin are transformed into stable paraffinic hydrocarbon. Metals, they are removed because they are deposited on catalysts in engines. Now, basic of hydrotreating. The common and assumed hydrotreating process is a single unit operation that converts all the raw feed into final desulfurized product. However, the most hydrotreatment process require many unit operations include reactor, gas separator, separation column, heat exchangers, and the process can divide into three main process blocks. They are heat exchange network, reactor with actually hydrotreating take place, and stripping where desulfurized product stream separated from the volatile gases and the impurities. Each hydrotreating unit tell feedstock and end product. For instance, the process hydrotreatment naphtha is not same process, the diesel fuel. The most common cuts they are hydrotreated in refinery include light naphtha, heavy naphtha, jet fuel, kerosene, diesel oil, light and heavy coker diesel oil. Now focus two main cuts, naphtha and diesel oil. The feed is first pressurized, mixed with recycle and make up hydrogen stream. The mixture heated 290 to 430 degrees centigrade. Before entering fixed bed reactor, they operate 7 to 180 bar. Higher temperature and pressure, they are used to processing heavier feedstock such diesel oil. Overall, hydrotreated temperature are relatively moderate. Avoid thermal cracking molecules. They are being high enough enable reaction of feedstock. Now inside fixed bed reactor, hydrogenolysis and mild hydrocracking reaction take place to convert sulfur, nitrogen, oxygen and other contaminants, hydrogen sulfide, ammonia, water vapor and other stabilized byproducts. The catalyst used in the reactor is a crucible design consideration that greatly affect final product in sulfur removal primary product. Cobalt molybdenum catalyst they are favored. If crude oil relatively low in sulfur nitrogen removal become the priority, nickel molybdenum catalysts are chosen depending on condition and composition outlet stream. The byproduct are either discarded, recycled and sent for the further treatment. Most outlet stream undergo further treatment to their environment impact and recover material for use. Sour gas, which contain hydrocarbon, carbon dioxide, significant amount of hydrogen sulfide that commonly sent to amine gas treating unit and separate hydrocarbon gases, hydrogen sulfide and carbon dioxide. During amine treatment, the carbon dioxide and hydrogen sulfide are absorbed amine solution in absorption unit, produce sweet gas and amine rich stream. Amine rich mixture is pumped desorption unit that is recovered, lean amine and recycled. Final product stream is a desulfurized product, fuel commonly called sweet gas. The importance of hydrogen. Hydrogen gas is one of the most important elements in the production of desulfurized fuel. Hydrotreating the hydrogen stream must be extremely pure, 99% greater than, have no humidity in stream, should have low hydrogen content as well as low mercaptan and hydrogen sulfide level less than 0.1%. Only 15 to 30% hydrogen demand refinery produce internally by process catalytic reforming naphtha. Rest is external product. The industrial use variety term hydrogen that depend how it is produced. Now, grey hydrogen is obtained natural gas via stream methane reforming and have smaller carbon footprint. Brown hydrogen. It has become the most common type hydrogen due to low price natural gas. Blue hydrogen is commonly produced from methane but differs from grey hydrogen but resulting carbon emission. They are captured and subsequent due to environmental restriction. Blue hydrogen is becoming more common. Brown hydrogen is obtained fossil fuel, coal, ignite via gasification. Gasification has large carbon footprint. It remains common way to produce hydrogen. Now hydrogen is produced feedstock, methane, pyrolysis. It associated very small carbon footprint because pyrolysis products include solid carbon, no carbon dioxide. Now green hydrogen produce any renewable energy source such as electrolysis of water via windmill of solar energy. It has not gained traction due to technology challenge and higher price. Now, hydrotreating naphtha. Naphtha is valuable byproduct petroleum refining. The main constitute gasoline, blending pool, while there are normal definition of naphtha commonly considered C5 to C12 cuts. It has divided light and heavy naphtha. Light naphtha has initial boiling point 30 degrees centigrade and final boiling point 140 degrees centigrade. It contains most of hydrocarbon between C4 and C6, heavy naphtha, initial boiling point and final boiling point about 140 degrees centigrade and final boiling point is 205 degrees centigrade respectively. It contains most of hydrocarbon C6 to C12. High sulfur content is associated with cuts and they are heavier naphtha. However, removing relatively small amount of sulfur in naphtha beneficial engine performance and operation. Heating naphtha feed enter hydrotreatment unit through charge pump. The first mix hydrogen gas either catalytic reforming unit or refinery hydrogen plant. The mixture is heated 340 degrees centigrade while being contacted with the reactor effluent. Charge heater 4 pass with 4 pass burner heater tube are constructed type 321 stainless steel, which is the grade choice for application temperature up to 900 degrees centigrade because combined higher strength and resistance to scaling with resistance aqueous corrosion. Now reaction. After preheating mixture fed to reactor, two catalytic bed, their desulfurization reaction take place, cobalt molybdenum bed, and their nitrogen reaction take place, alumina bed. The reactor temperature is held constant 350 degrees centigrade and pressure 370 psi. The reactor effluent contain mostly desulfurized naphtha, excess hydrogen, hydrogen sulfide, ammonia, light hydrocarbon, C1 to C4. Due to mild cracking, the reactor effluent cooled partially condensed. Feed effluent heat exchanger, then cooled with air. Heating. The raw untreated diesel oil pump directly heat exchange network. Hydrotreating process are designed with heat exchange network that are paired lower thermal feed reactor while required heating, higher temperature reactor effluent that require cooling. Reaction. Heated feedstock mixed with hot recycled hydrogen stream, recover downstream process, and mixture is sent reactor depending sulfur content stream either cobalt molybdenum bed, nickel molybdenum, and alumina bed, which is used because high sulfur fuel. They are mostly common in industries today. Sulfur removal is typically the focus. Diesel oil hydrotreating. Effluent reactor include off gases removed, separator, light end that will treated, sent to naphtha unit and unstabilized diesel oil. Separation. Reactor effluent is cooled in heat exchange network. The fresh liquid condensed from lighter cut and crude distillation unit injected into the reactor effluent avoids salt formation. Downstream unit operation, the mixture is flashed into higher pressure separator drum producing liquid byproduct ammonia. Solution site refinery, wastewater system and hydrogen rich gas that contain hydrogen sulfide. The gas they are sent absorber to remove hydrogen sulfide, circulating diammonia solution. The resulting hydrogen stream combined make up hydrogen and injected feedstock stream enter the initial hydrotreatment reactor. Now stabilize diesel oil from the flash drum, depressurize successive flash drum. The process desulfurization favor gas formation. Further stabilize liquid hydrocarbon. Flash gas is sent hydrogen sulfide. Removal before going refinery fuel system. The bottom liquid stream are formed. Second flash drum preheated and sent the stabilizer column and stabilizer column produce three main cut naphtha gas recovered naphtha to be combined with naphtha stream and the desulfurized stabilized diesel. Now challenge for future hydrotreating. Hydrotreating is critical addressing challenges refinery facing today. Fuel consumption worldwide is increasing, putting pressure on refiner, increases production. Additional lower sulfur crude oil are becoming scarce and forcing refinery contended higher sulfur feedstock while meeting increasingly tight restriction sulfur concentration in fuel. Addressing compound challenge require development application catalytic technology that improve reaction rate, conversion, overall performance. Hydrotreatment process current catalytic suffer selectively issue. They could be overcome alternative technology. Titanium dioxide and zirconium dioxide are catalysts. Another factor to consider hydrogen gas requirement. Hydrotreatment process refinery typically operate hydrogen deflect requirement purchase of the hydrogen from outside vendors. As environment restrictions become tight, refinery will separate explore hydrogen sources with small carbon footprint. Now separation. Separation process stripping section and separator and column destabilize naphtha. They are liquid naphtha stream. They are separator send the stripping unit and the stripping column heated 340 degrees centigrade reboiled and held pressure 205 psi high pressure and pressure enable removal volatile material like hydrocarbon which would vaporize final storage condition inlet and stripping column include desulfurized raw naphtha, recycled desulfurized strip naphtha and bottom of column. The outlet stream include mostly light gases C1 to C5 hydrocarbon. They are sand, amine treatment, recovery, and fuel, resulting naphtha, cooled air and sent the unit, battery unit, stabilize hydrotreated naphtha product. Now, hydrotreating diesel oil. Their diesel oil are either direct cut from the atmospheric distillation column or mixture, light cycle oil, fluid catalytic cracking, and heavily cycled the delay coker out of 1 to 2% sulfur, much higher than the requirement 10 to 15 part per million. Therefore, hydrotreating, one of the most important steps processing diesel oil specification, it removes sulfur and impurity nitrogen and olefin. They are addition hydrotreatment, saturated olefin removal double bonded carbon with diesel oil and the process increases stability and decrease volatility, diesel enabling longer storage. Refinery around the world starving to meet growing demand, cleaner fuel, ensuring cost-effective operation, getting the greatest value out of the crude oil and effective processing the fraction from the very light gas and naphtha and residue can challenging offer hydrotreating catalyst and technology, crude oil fraction, now enabling refining to meet product specification, lower cost and higher profit. The solutions are built over 40-year experience dedicated to meeting customer needs through innovation. Now, hydrotreating, naphtha hydrotreating future. Our extensive range naphtha hydrotreating catalysts and technology are designed handle all feedstock and still ensure easy, reliable, stable and profitable hydroprocessing, superior process design, high performance catalyst and priority equipment ensure significant longer cycle length while increasing plant availability. Okay guys, this is up to our today's topic hydrotreating. I hope you get sufficient knowledge after watching this video on YouTube. Next Sunday we have covered some another chemical engineering topic. Till then, goodbye. Do take good care of yourself and wishes you a very happy Sunday.